The theory that science banned from TED. Did you know that there's a talk that was literally censored, removed from the TED platform, and banned from free circulation on the scientific internet? We're not talking about absurd conspiracy theories, we're not talking about cheap pseudoscience or New Age quackery. We're talking about a theory presented by a respected British biologist with a PhD from Cambridge, who worked alongside a Nobel Prize winner and whose talk was deleted from the official TEDx channel because what he said was deemed too dangerous to be publicly debated. His name is Rupert Sheldrake, and his theory challenges the very foundations of modern scientific materialism. But before you think this is just another story about a mad scientist rejected by academia, I need to tell you something that will make you question everything you've learned about how science really works. Because what happened to Sheldrake wasn't an isolated case of academic censorship. It was a symptom of something much larger, much deeper, and much more disturbing about how the scientific establishment deals with ideas that threaten its dominant paradigm. And when you understand what's really at stake in this story, you'll realize we're not just talking about a controversial theory. We're talking about the limits of human knowledge, about dogma masquerading as science, and about questions that modern physics and biology simply can't answer without admitting that there's something fundamentally wrong with our materialistic worldview. The story begins in January 2013, when Rupert Sheldrake takes the stage at a TEDx conference in London to deliver a talk titled Science as Dogma. For 18 minutes, he does something few scientists dare to do publicly. He questions the fundamental dogmas of materialist science. He doesn't attack the scientific method itself, nor does he deny the importance of experimentation or empirical evidence. What he does is far more subversive. He questions the metaphysical assumptions that underpin all modern science, those invisible premises that no one dares to question because they are treated not as testable hypotheses, but as absolute, unquestionable truths. Sheldrake lists 10 dogmas of materialist science, and each of them, upon closer examination, reveals itself not as proven fact, but as philosophical belief. The first of these beliefs is that nature is mechanical, that the entire universe operates like a giant machine governed by fixed and immutable laws. The second is that matter is unconscious, that consciousness is merely an epiphenomenon of the material brain. The third is that the laws of nature are fixed and eternal, immutable since the Big Bang, and so on. Sheldrake does not deny that these assumptions have been useful for the development of science over the past 300 years. What he questions is whether they are true, whether they are the only possible ways to understand reality, and whether empirical evidence actually supports or contradicts them. The talk was initially posted on the TEDx channel like all the others, but something extraordinary happened. Complaints began to pour in. Orthodox materialist scientists, militant skeptics, and advocates of conventional scientific thought began bombarding TED with emails and petitions demanding its removal. They didn't argue that Sheldrake was factually wrong on specific points that could be debated and refuted through normal scientific dialogue. Instead, they argued that the talk's very existence was harmful, that it legitimized dangerous ideas, that it could confuse the public and undermine trust in science. TED, which prides itself on being a platform for ideas worth spreading, caved to the pressure. They not only removed the talk from the main channel, but also created a special section called Controversial Conversations, where Sheldrake's talk was placed alongside another equally banned talk, accompanied by lengthy disclaimers explaining why those ideas were problematic and why TED didn't endorse their content. It was an unprecedented moment in the platform's history. Thousands of TEDx talks have been published over the years, many of them presenting speculative, controversial, or unproven ideas, but only 2 were deemed so dangerous that they essentially needed to be censored, and one of them was Rupert Sheldrake's talk on the dogmas of science. Now, you need to understand who Rupert Sheldrake is to fully appreciate the irony and significance of this censure. He's not an uncredentialed outsider trying to tear down science from the outside. Sheldrake earned his PhD in biochemistry from the University of Cambridge, was a Fellow of the Royal Society, worked at Clare College, Cambridge, and spent years researching cellular development and plant aging in India. He has authored over 90 scientific papers, published in peer-reviewed journals, and written numerous books, some of which have become international bestsellers. This is no ignorant charlatan or uneducated conspiracy theorist. This is a legitimate scientist, trained at the heart of the British scientific establishment, who has decided to question the philosophical foundations of his own discipline. And that's precisely why he's so dangerous to the establishment. Because when an outsider criticizes science, it's easy to dismiss them as ignorant. But when an insider, someone with all the right credentials and all the appropriate training, raises fundamental questions about the unexamined assumptions of modern science, it creates a much bigger problem. It suggests that there may be real flaws in the dominant paradigm, flaws that cannot be easily explained or dismissed. Sheldrake's most controversial theory, the one that truly put a target on his back, is called morphic resonance. To understand this theory, you first need to understand a fundamental problem in biology that almost no one outside academia knows about. Modern molecular biology operates under a paradigm called genetic determinism, the idea that genes determine essentially everything about an organism. Your genes code for proteins, these proteins interact in complex ways, and from these interactions emerge everything from your body shape to the behavior patterns of your species. It's a beautiful, elegant, and mathematically tractable story. The only problem is that it doesn't work. Genes don't contain enough information to explain the complexity of organisms. The human genome has about 20,000 genes, not much more than an earthworm. There isn't enough information in genes to specify the precise connections of the billions of neurons in the human brain, or to explain how a developing embryo knows to grow a left and a right arm in the correct orientation. There's something else going on, something that genes alone can't explain. Mainstream biologists try to fill this gap with vague references to complex interactions and emergent properties. But these are just fancy words for "we don't know." This is where Sheldrake proposes something radical. He suggests that the form and behavior of organisms are determined not only by genes and molecular interactions, but also by morphic fields, information fields that contain a kind of collective memory of the species. These fields aren't composed of matter or energy in the conventional sense. They are form fields, pattern fields, habit fields. And here's the really controversial part. These fields operate through something called morphic resonance, a process by which members of a species can influence other members of the same species across space and time without any material connection between them. In other words, when a rat in London learns a new trick, it makes it easier for rats in New York to learn the same trick, not because there's any direct communication between them, but because the act of learning creates a change in the species' morphic field that then influences all other members of the species. Sounds crazy, right? It sounds like magic, not science. But here's the thing. Sheldrake isn't just speculating philosophically. He points to actual experimental evidence that suggests something like this might actually be happening. One of the most famous examples comes from experiments conducted in the 1920s by William McDougall, a Harvard psychologist. McDougall trained rats to escape from a water tank by finding the correct exit in a maze. He found that it took many attempts for the first rats to learn, but as successive generations of rats were trained, they learned progressively faster, as if each generation was somehow benefiting from the learning of previous generations. This could be explained genetically through natural selection, but there was a problem. When the experiment was replicated in Scotland and Australia with rats that were genetically unrelated to the Harvard rats, these rats also learned quickly from the start, as if they were benefiting from the learning of rats half a world away. The results were published in respected scientific journals, but were largely ignored because they didn't fit the prevailing paradigm. There was no known mechanism by which this could happen, so most scientists simply dismissed the results as experimental anomalies or statistical flukes. But Sheldrake sees these experiments as evidence of something real, something that materialist science cannot explain, because it is fundamentally committed to the belief that all causality must be local and material. Sheldrake cites numerous other examples of phenomena that seem to defy purely materialistic explanations. There's the phenomenon of new crystals that are initially difficult to grow in a laboratory but become progressively easier to grow in laboratories around the world, even when there's no possibility of cross-contamination. There are studies on crossword puzzles that show that people find it easier to solve crosswords published after many people have already solved them, even when they haven't had access to the answers. There are experiments on language learning that suggest that common linguistic patterns are easier to learn than rare patterns, even when both are equally logically simple. And there's the famous phenomenon of dogs knowing when their owners are coming home, even when the owners return at random, unscheduled times, suggesting some form of telepathic connection between pets and their humans. Now, you can look at any of these examples individually and find plausible conventional explanations. Perhaps the crystals are contaminated by microscopic dust particles traveling between laboratories. Perhaps people are better at solving crosswords simply because newer crosswords follow more familiar patterns. Perhaps dogs simply respond to subtle cues in the environment that humans don't notice. The scientific establishment certainly has ready-made explanations for each individual anomaly. But here's what Sheldrake argues, and this is really the heart of his critique of materialist science. When you have hundreds of anomalies, all pointing in the same direction, all suggesting that there are non-local connections operating in nature, at some point you have to question whether the problem lies with the anomalies or with the paradigm that defines them as anomalous. Materialist science is fundamentally committed to the idea that all causality is local and material, that everything that happens in one place can only affect another place through direct physical interactions involving known particles or force fields. It's a metaphysical assumption, not an empirical discovery. And when you commit to this assumption absolutely, then any evidence of non-local connections must be dismissed or explained away, no matter how strong or consistent the evidence. You become trapped in a system of circular reasoning where your basic assumptions determine what evidence you're willing to take seriously. This isn't science, it's dogma disguised as science. And that's exactly what Sheldrake was trying to expose in his censored TEDx talk. Now, let's talk about why this matters. Why this isn't just an esoteric dispute between philosophers of science. Because what's really at stake here is the nature of consciousness, the meaning of life, and our understanding of our place in the universe. The materialist worldview that dominates modern science tells us that we are complex biological machines, that our consciousness is merely a byproduct of electrical activity in the brain, that our thoughts and feelings are illusions generated by neurochemical processes, and that when our brains die, we cease to exist. It's a nihilistic and depressing worldview, but it's presented as the inevitable verdict of rational science. Any alternative suggestion, any evidence that consciousness might be more than just brain processes, is automatically labeled as magical thinking, wishful thinking, or pseudoscience. But what if materialism isn't really what the evidence tells us? What if it's just a philosophical choice, one among many possible ways to interpret the data? Sheldrake argues that real empirical evidence points to a universe far more interconnected, far more alive, and far more mysterious than materialism allows. A universe where consciousness may not be reducible to brain processes, where non-local connections between minds may be real, where memory may not be stored solely in neural synapses, but in information fields that transcend the individual brain. Let's delve deeper into one of Sheldrake's most powerful arguments against materialism, the problem of memory. Conventional neuroscience assumes that memories are stored in the brain as patterns of synaptic connections between neurons. When you remember something, you're accessing these stored patterns. It's a beautiful and intuitive model based on the analogy of computers, where memory is stored in physical hardware. The problem is that there's no solid empirical evidence that memory actually works this way. Decades of research trying to pinpoint specific memories in the brain have failed. You can remove large portions of the brains of experimental animals, and while their ability to form new memories may be impaired, their old memories remain largely intact. The famous neuroscientist Carl Lashley spent 30 years searching for the engram, the physical trace of memory in the brain, and was never able to find it. In his final paper, he joked that the evidence suggested memory was impossible. But instead of questioning the memory storage model, neuroscience has simply assumed that memory must be distributed throughout the brain in such complex ways that we cannot yet detect it. Once again, the paradigm determines how we interpret evidence. Sheldrake proposes a radical alternative. What if memories are not stored in the brain, but accessed by the brain through morphic resonance? In this model, the brain functions more like a radio receiver than a storage device. It tunes into memory fields that exist beyond the physical brain. This would explain why memories persist even when brain tissue is damaged, why it is so difficult to pinpoint specific memories, and why phenomena like collective memory and ancestral memory appear in so many different cultures. And it's not just memories that defy materialist explanation. There's the problem of consciousness itself, the so-called hard problem of consciousness made famous by philosopher David Chalmers. How do objective physical processes in the brain give rise to subjective experiences? How does electrical activity transform into qualia, the sensation of red, the taste of coffee, the feeling of being in love? Neuroscience can map correlations between brain states and mental states down to the finest detail, but correlation is not causation, and no amount of correlation mapping explains why there should be such a thing as subjective experience. The standard strategy of materialist neuroscience is to deny that there's a real problem here, to argue that consciousness is just an illusion or an epiphenomenon with no causal power, or that it will eventually be explained once we understand the brain well enough. But these aren't really explanations. They're avoidance strategies, ways of indefinitely postponing the need to confront what the evidence is really telling us. That consciousness doesn't fit into the materialist framework. Sheldrake is willing to consider seriously the possibility that consciousness is fundamental, not derivative, that it is a basic feature of reality rather than an accidental byproduct of material processes. And if this is true, then everything changes. The entire reductionist project of modern science, the attempt to explain everything in terms of mindless particles following mathematical laws, falls apart. We need a completely new science, one that can deal with mind, meaning, and purpose as real features of the universe rather than illusions to be explained. And here's where we get really controversial, where Sheldrake goes even further and starts talking about things that make even open-minded scientists cringe. He takes the possibility of paranormal phenomena seriously. Not as tabloid entertainment or superstition, but as potentially legitimate areas of scientific inquiry that have been prematurely dismissed by the scientific establishment. He points out that there are thousands of experiments published in peer-reviewed journals on telepathy, clairvoyance, precognition, and psychokinesis. Most show only small and statistically marginal effects, but the effects are there, consistently replicated in dozens of laboratories around the world. Sophisticated statistical meta-analyses show that the effects are real and cannot be explained by publication bias or poor experimental methodology. But the vast majority of scientists simply ignore this research because it contradicts their basic materialist assumptions. If telepathy is impossible in principle, then no amount of experimental evidence can prove it, and any positive experimental results must be due to fraud, error, or statistical artifact. Once again, dogma determines what counts as acceptable evidence. Sheldrake argues that we need a more open, empirically oriented science, willing to investigate phenomena even when they don't fit existing paradigms. After all, that's how science should work. You don't start with a metaphysical ideology and then force the data to fit it. You look at the data with an open mind and build your theories to explain them, going wherever the evidence leads, even if that means questioning your most basic assumptions. But here's the real reason Sheldrake's theory was banned from TED, the reason the scientific establishment considers it so dangerous. It's not because it's scientifically invalid or based on bad evidence. It's because it threatens the cultural authority of materialist science. We live in an age where science has replaced religion as the ultimate source of truth and meaning for many people. Scientists have become the new priests, and scientific materialism has become the new orthodoxy. And like any orthodoxy, it defends its territory fiercely against challengers. When someone like Sheldrake comes along and says the emperor has no clothes, that materialism is just a philosophical assumption no more proven than any other metaphysics. It undermines the entire authority structure. If materialism is just a belief rather than a proven fact, then materialist scientists have no more authority to tell people what the universe really is than philosophers or theologians or mystics. The entire power play collapses. And that's why Sheldrake must be silenced, not refuted through normal scientific debate, but simply removed from the conversation, banned from the platform, treated as a heretic rather than a legitimate intellectual opponent. This is the scientific inquisition in action, proving Sheldrake's point better than he could have done on his own. What makes all this even more ironic is that physics itself, the most fundamental of sciences, abandoned materialism over a century ago. Quantum mechanics, the most successful and empirically validated theory in the history of science, is profoundly non-materialist. It tells us that particles have no definite properties until observed, that reality is fundamentally probabilistic rather than deterministic, that particles can be entangled across arbitrary distances in apparent violation of locality, and that the act of observation plays a fundamental role in creating reality. Physicists have debated the philosophical significance of these discoveries for a century and have yet to reach a consensus. Some interpretations of quantum mechanics are materialist, others are not. The famous physicist Eugene Wigner argued that consciousness must be fundamental to explaining the collapse of the wave function. John von Neumann showed mathematically that the quantum measurement chain must end with a conscious observer. And John Wheeler's delayed choice experiment suggests that choices made in the present can apparently influence events in the past, challenging our basic notions of causality and time. Neither of these things fits comfortably into a materialist framework, but physicists have learned to live with the ambiguity. It is only in biology and neuroscience, disciplines that should be aware of the lessons of physics, that hard materialism still reigns supreme. It is as if biologists and neuroscientists are doing 19th century science while pretending to do 21st century science. Sheldrake also points to another central tenet of materialist science that is rarely questioned, the idea that the laws of nature are fixed and eternal. We learn in school that there are fundamental laws of physics that govern the behavior of everything in the universe, and these laws are the same everywhere and at all times. They were the same a second after the Big Bang and will be the same billions of years from now. But where do these laws come from? How can they exist before the universe existed? And how can they be immutable when everything else in the universe evolves and changes? Sheldrake proposes a radical alternative. What if the laws of nature are not laws at all, but habits? What if the universe, like the organisms within it, learns and evolves, and what we call natural laws are actually just deeply ingrained patterns established over billions of years of repetition? In this view, the fundamental constants of physics may not actually be constant. They may be slowly changing over cosmic time. And new patterns, new possibilities, may emerge as the universe evolves. This is speculative, admittedly, but no more speculative than the orthodox assumption of eternal, immutable laws imposed by no one knows what. And Sheldrake points out that there is intriguing evidence that the fundamental constants may indeed be changing. Measurements of the fine structure constant, one of the most important constants in physics, show small variations when measured at different times and places in the universe. These variations are within the margins of experimental error, so they are not conclusive, but they are suggestive. If real, they imply that the universe is much more fluid and evolutionary than standard physics assumes. Now let me be clear about something important. Sheldrake is not arguing that we should abandon the scientific method or return to some pre-scientific mysticism. He is arguing for the opposite. He wants science to be more scientific, more empirically oriented, more willing to question its own assumptions and follow the evidence wherever it leads. The problem with materialist science is not that it is too scientific, but that it is not scientific enough. It clings to philosophical assumptions that are not empirically justified and refuses to seriously consider phenomena that do not fit those assumptions. True science should be agnostic about metaphysics. It should be willing to investigate any phenomenon that is empirically detectable, regardless of whether it fits existing theories. It should be willing to abandon theories when they fail to explain the evidence, no matter how elegant or philosophically satisfying those theories are. And above all, it should be willing to admit ignorance when it doesn't know something, rather than pretending to have answers when all it really has are promissory notes of future explanations. This intellectual humility, this honesty about the limits of current knowledge, is what separates true science from scientific dogma. And it's what makes Sheldrake's work so important and so threatening to orthodoxy. There is also a deeply personal and existential dimension to this debate that goes beyond abstract scientific arguments. If Sheldrake is right, if the universe is truly more interconnected and more alive than materialism allows, then this fundamentally changes how we should live our lives. In a materialistic universe, we are essentially alone, temporary biological machines condemned to exist for a few decades before returning to nothingness. There is no cosmic meaning or purpose, only the local and temporary significance we manage to create for ourselves before we die. It's a worldview that logically leads to nihilism and despair, though most people are psychologically incapable of truly living up to it and thus develop all sorts of philosophical inconsistencies to make life bearable. But in a universe where consciousness is fundamental, where we are connected through invisible fields that transcend space and time, where memory and meaning persist beyond physical death, then suddenly life looks very different. So there is a spiritual dimension to existence that is not just magical thinking or self-delusion, but a real feature of the structure of the universe. So our feelings of connection with others, with nature, with something greater than ourselves, are not just adaptive illusions generated by our primate brains to promote survival. They are direct perceptions of real aspects of reality that materialistic science tells us to ignore. And maybe, just maybe, death is not the final end that materialism insists it is. This brings us to one of the most provocative and controversial implications of Sheldrake's theory, the possibility of some form of life after death. Now, before you completely close your mind to this, consider this. If memory isn't stored in the brain but accessed through morphic fields, then what happens to those memories when the brain dies? In the materialist view, they simply cease to exist when the hardware that stores them breaks down. But if memory exists in fields that transcend the individual brain, then it's at least logically possible that those memories persist after physical death, even if there's no longer a brain to access them in the usual way. Sheldrake doesn't make definitive claims about this, but he's willing to consider the possibility seriously based on the logic of his theory. And he points out that there's intriguing empirical evidence from near-death experiences, past life memories in young children, and other phenomena that suggest consciousness may not be as brain-dependent as materialists assume. Again, these are highly controversial areas of research, and the evidence is by no means conclusive. But there is evidence, published in reputable medical and psychological journals, and it deserves to be taken seriously rather than dismissed on principle. The fact that most scientists are unaware of this research, or dismiss it without examining it, says more about the limits of the current scientific paradigm than about the validity of the phenomena being studied. Let's discuss another aspect of Sheldrake's theory that has profound implications for how we understand evolution. The standard evolutionary theory, neo-Darwinism, explains the complexity and diversity of life through random mutation and natural selection. It's a powerful mechanism that clearly plays an important role in evolution. But is it sufficient to explain all the complexity we see? Sheldrake argues that it isn't. He points out that neo-Darwinian theory faces serious problems, explaining the origin of complex structures, the Cambrian explosion when most animal body plans arose in a geologically short period, and the apparent directionality of evolution toward greater complexity and consciousness. Random mutation and natural selection can explain incremental adaptive changes, but they can also explain evolutionary novelties, radical changes, the emergence of completely new properties, the seemingly coordinated emergence of multiple changes that must work together to produce an adaptive advantage. Sheldrake suggests that morphic resonance may provide an additional mechanism that works alongside natural selection. When a species develops a new behavior or trait, it alters the species' morphic field, making it more likely that other members of the species will develop similar traits even without direct genetic inheritance. This would accelerate evolution and explain why similar evolutionary changes often occur independently in unrelated lineages, a phenomenon called convergent evolution. Standard theory attributes convergent evolution to the fact that similar problems have similar solutions, which is true, but it doesn't fully explain why the solutions are often so strikingly similar at the molecular and structural level. Morphic resonance would provide a mechanism through which evolutionary innovations could spread more rapidly through populations and even across species, creating a kind of collective evolutionary memory that complements the genetic memory stored in DNA. There are also fascinating implications for how we understand embryonic development. One of the greatest mysteries in biology is how a developing embryo knows how to grow into the right shape. You start with a fertilized egg, a single cell, and through repeated cell divisions, you end up with a complete organism with a heart, brain, and limbs, all in the right place and functioning together in a coordinated manner. The standard explanation is that all of this is encoded in genes and the molecular interactions they control. But when you really examine the details, it becomes clear that this cannot be the whole story. Genes specify proteins, not shapes. There is nothing in DNA that resembles a blueprint for a body. There is no specification of where the heart should be in relation to the liver, or how to organize billions of neurons into a functioning brain. Developmental biologists talk about morphogenetic gradients and genetic signaling cascades, but these are descriptions of processes, not explanations of how form is generated. Sheldrake proposes that morphic fields provide the organizational models that guide development. DNA provides the building materials, but morphic fields provide the architectural blueprint. This would explain why you can remove cells from an early developing embryo, and the remaining cells will rearrange themselves to form a complete organism, something that would be impossible if development were rigidly determined by local genetic instructions. Morphic fields provide a level of organization above genes, an informational template that exists beyond the molecular level. And this brings us back to one of the most profound questions you can ask. Where does information come from? Molecular biology tells us that information is in genes, encoded in the base sequence of DNA. But this answer only pushes the question back a step. Where did the information in genes come from? The standard evolutionary answer is that it gradually accumulated through natural selection over billions of years. But natural selection is a process of editing, not creation. It can select among existing variations, but it cannot create the information in the variations in the first place. Random mutations can scramble existing information or corrupt it, but it is mathematically very unlikely that they create genuinely new information of the kind needed to build complex biological structures. Information theorists have calculated that the amount of information required to specify even a single functional protein is beyond what random mutations could plausibly generate in the time available since the origin of life. Orthodox biologists argue that since life exists and is evolving, it obviously happened, and our inability to fully explain how is merely a gap in knowledge that will eventually be filled. But Sheldrake suggests that perhaps biological information comes not only from below, from gradually accumulating random mutations, but also from above, from organizational fields that transcend the molecular level. If this is true, then life is much more than just complex chemistry. There is an organizational principle at work in nature that materialistic science fails to recognize and cannot explain. Now, let's address the obvious objection you're probably thinking. If Sheldrake's theory is so good, why hasn't it been widely accepted by the scientific community? Why does he remain a marginal figure while the scientific mainstream remains committed to materialism? The easy answer, the one Sheldrake's critics will give, is that his theory is wrong, that it's unsupported by evidence, that it's pseudoscience masquerading as real science. But when you really examine the critics' arguments, they tend to be remarkably weak. They rarely address the actual empirical evidence Sheldrake presents. Instead, they simply claim that the phenomena he describes are impossible because there's no known mechanism through which they could occur. But this is classic question begging. Of course, there's no known mechanism. That's precisely why Sheldrake is proposing a new mechanism. Saying that morphic resonance can't be real because we don't know how it works is like saying that gravity can't be real because we don't know how it works. Newton had no idea how gravity worked. He simply described it mathematically, but that was enough to revolutionize physics. Sheldrake is trying to do something similar for biology, identifying and organizing principle that operates in nature, even if we can't yet fully explain the mechanism in terms of known physics. The real reason Sheldrake's theory remains marginal is sociological, not scientific. Thomas Kuhn, in his seminal work, The Structure of Scientific Revolutions, explained how science actually works versus how it should work in theory. In theory, scientists are rational empiricists who follow the evidence wherever it leads. In practice, scientists are humans working within established paradigms, and they fiercely resist paradigm shifts, even when evidence is mounting against the existing paradigm. Paradigms shift, not because individual scientists are convinced by new evidence, but because the older generation of scientists committed to the old paradigm eventually dies and is replaced by a younger generation willing to consider new ideas. In Max Planck's famous words, "Science advances one funeral at a time." Sheldrake is proposing a fundamental paradigm shift, from materialism to a more holistic, organismic worldview. This kind of shift does not happen easily or quickly. It threatens careers, reputations, funding structures, and entire research programs. People who have spent decades working within the materialist paradigm won't simply abandon it because a few anomalous experiments suggest there might be something wrong with it. They will defend the paradigm, rationalize it, attack critics, and do everything they can to maintain the status quo. This isn't necessarily conscious malice. It's just human nature and the sociology of how scientific institutions actually work. But there are signs that the materialist paradigm is beginning to crack, that we are possibly on the verge of a Kuhnian shift. More and more scientists, particularly quantum physicists and neuroscientists studying consciousness, are publicly questioning materialist assumptions. There is a growing recognition that the hard problem of consciousness is truly hard, that it won't go away simply by mapping correlations between brain and mind. There is renewed interest in anomalous phenomena that were previously dismissed, and there is a younger generation of researchers who grew up in a world where quantum physics and complexity are taken for granted, and who are less invested in defending 19th century materialist reductionism. Sheldrake may be ahead of his time, but that doesn't necessarily mean he's wrong. The history of science is full of examples of visionary thinkers whose ideas were initially dismissed only to be vindicated decades or centuries later. Gregor Mendel, the founder of genetics, had his work ignored during his lifetime. Alfred Wegener, who proposed continental drift, was ridiculed by the geological community. Lynn Margulis, who proposed that mitochondria and chloroplasts were originally symbiotic bacteria, was rejected for years before her theory was accepted. Sheldrake may be in good company among the scientific heretics who were right all along. Let's also consider what's at stake culturally and spiritually. We live in a time of crisis of meaning. Traditional religions have lost their authority for many, but the materialistic science that has replaced them offers a deeply unsatisfactory narrative about human meaning and purpose. We are accidentally generated through blind evolutionary processes, condemned to live for a few decades before returning to the non-being from which we came, and everything we do is ultimately meaningless against the backdrop of an indifferent universe slowly deteriorating toward heat death. It's no wonder we have epidemics of depression, anxiety, and meaninglessness. It's no wonder people seek meaning in nationalism, tribalism, consumerism, or extreme political ideologies. The void left by the death of God and the inability of materialistic science to fill it is creating a spiritual crisis of historic proportions. What Sheldrake offers is not a return to traditional religion, but a reconciliation of science and spirituality. A worldview that is empirically grounded and scientifically respectable, but also makes room for meaning, purpose, connection, and transcendence. A universe that is simultaneously material and mental, mechanical and living, governed by laws, but also capable of creative novelty. This is a narrative that can potentially fill the void of meaning that materialism has created, providing a scientific basis for a naturalistic spirituality that does not require supernatural beliefs, but recognizes that there is more to reality than just atoms and emptiness. The question each of us needs to ask is, what worldview best fits the totality of human experience? Scientific materialism can explain much about the physical world. It can build impressive technology, cure diseases, and predict the movements of the planets. But can it explain consciousness? Can it explain why there is something rather than nothing? Can it explain love, beauty, meaning, the direct experience of subjective existence? Can it explain the experiences of deep connection with others, with nature, with something greater than ourselves that so many people report? The materialist will say that all of these things are illusions, tricks our brains play on us to help our genes replicate. But is this answer satisfactory? Is it even an answer, or is it just a way of avoiding the question? Sheldrake is asking us to be honest about the limits of materialism, to admit that there are aspects of reality it cannot explain and may never be able to explain, because it is fundamentally committed to an ontology too narrow to capture the full richness of existence. This does not mean abandoning science. It means expanding science beyond the self-imposed limitations of philosophical materialism. And here's something crucial to understand. Sheldrake isn't asking you to believe his theory based on faith or authority. He's proposing testable experiments. Morphic resonance makes specific predictions that can be verified or falsified through carefully designed experiments. He's spent decades designing and conducting such experiments, many in collaboration with other scientists, and the results have been intriguing. They're not conclusive, the evidence isn't overwhelming, but there's something there. There are small but replicable effects that suggest something like morphic resonance might be at work. The problem is that these experiments are underfunded and neglected because they don't fit the dominant paradigm. It's hard to get funding for research that challenges fundamental assumptions. Hard to publish results in major journals when reviewers are hostile to your theoretical framework. Hard to build a research community when you're working outside the mainstream. But the work continues, slowly accumulating evidence, gradually building a case that eventually can't be ignored. Real science works slowly, especially when it's challenging established orthodoxies. But it works, eventually. Truth has a way of emerging over time, no matter how many obstacles are placed in its path. Let me share some of the specific experiments Sheldrake conducted that provide intriguing support for his theory. One of the most famous involves the phenomenon of people sensing when they are being watched. Almost everyone has had the experience of feeling a gaze on their back, turning around, and discovering that someone was indeed looking at them. Conventional psychology dismisses this as confirmation bias. You remember the times you were right and forget the times you were wrong. But Sheldrake designed controlled experiments in which people are paired, one looking at the other's back at random times, and the person being stared at has to guess when they are being watched. These experiments have been conducted thousands of times with tens of thousands of participants, and the results consistently show that people guess correctly above chance. The effect is small, but statistically significant and replicable. Even more carefully controlled versions using closed cameras and TV monitors, eliminating any possibility of subtle sensory cues, show similar results. This suggests that there is some kind of direct influence of attention that extends beyond the known physical senses. It is exactly the kind of phenomenon that morphic resonance would predict, a direct mind-to-mind connection that operates through fields that transcend normal sensory channels. Another experiment involves the phenomenon of pets knowing when their owners are coming home. Sheldrake has collected thousands of reports from pet owners whose dogs or cats seem to know when their owners are returning, often going to the window or door exactly when the owner decides to return, even when this happens at random and unpredictable times. Skeptics argue that the animals are simply responding to predictable routines or subtle sounds of an approaching car. But Sheldrake has carefully designed experiments where owners return at completely random times determined by beepers, where they use taxis instead of their own cars, and where the animal's behavior is continuously videotaped. The results show that many animals actually begin to behave anticipatorily, precisely when their owners decide to return, not when they actually arrive, and regardless of the transportation they use. This suggests some kind of direct telepathic connection between animals and their humans, exactly what you would expect if there were morphic fields connecting closely related organisms. Again, it is not conclusive proof, but it is suggestive evidence that deserves to be taken seriously rather than dismissed on principle. Sheldrake has also conducted experiments on what he calls phone call premonitions. You've probably had the experience of thinking about someone, only to have the phone ring and it be that very person. Again, skeptics attribute this to chance and confirmation bias. But when you actually test this experimentally, giving people 4 possible callers and asking them to guess before answering, the results show success rates significantly above the 25% you'd expect by chance. The effect is strongest with emotionally close people, which makes sense if there's a morphic field connecting closely connected people. Modern versions of these experiments using email and text messages show similar results. There's something going on here that conventional science can't easily explain. It's not magic, it's not supernatural, but it suggests that there are aspects of human communication and connection that operate beyond known sensory and communication channels. Perhaps most provocative of all are the remote viewing and precognition experiments conducted not by Sheldrake, but by other researchers, whose existence and results Sheldrake uses to support his broader ideas. Decades of research, much of it originally funded by military intelligence agencies during the Cold War, have shown that some people can describe remote locations they have never visited with accuracy above chance, and that some people can predict random future events better than would be expected by guesswork. Statistician Jessica Utz, in a review of remote viewing research for the U.S. government, concluded that the effects were real and comparable in magnitude to the effects of some accepted medical treatments. But because these results contradict basic materialist assumptions about space, time, and causality, They are largely ignored by the mainstream scientific community. Sheldrake argues that if we are to have a truly empirical science, we must be willing to investigate phenomena even when they do not fit existing theories. The history of science repeatedly shows that today's unexplained anomalies become tomorrow's established science. X-rays, radioactivity, superconductivity, all were initially seen as impossible or mysterious before being integrated into our scientific understanding. The phenomena Sheldrake and others are studying may be the anomalies that eventually force a rethinking of our understanding of consciousness and its relationship to the physical world. But let's be honest about something. Even if all the evidence Sheldrake presents is accepted at face value, it still doesn't conclusively prove his morphic resonance theory. Science never proves anything conclusively. It merely accumulates evidence that makes certain theories more or less plausible. And there are alternative theories that could potentially explain some of the same phenomena. Perhaps there are aspects of quantum physics we don't yet fully understand that could explain non-local connections between organisms. Perhaps there are information fields based on known physical principles that we simply haven't discovered yet. Perhaps consciousness is a quantum phenomenon that enables types of information processing that seem classically impossible. There are numerous speculative theories floating around trying to make sense of the same anomalies Sheldrake is addressing. What makes Sheldrake's approach distinctive is his willingness to propose a new organizing principle rather than trying to force everything to fit into existing physics. He's willing to say that perhaps reality really is weirder than physics currently allows, that perhaps we need to expand our basic ontology to include new kinds of entities like morphic fields. This is philosophically more radical, but it may also be more honest about the depth of the problems we face in trying to understand life and consciousness within a purely materialist framework. Which brings me to my final and most important point. Whether Sheldrake is right or wrong about the specifics of morphic resonance, he is absolutely certain that modern science suffers from dogmatism, which treats certain philosophical assumptions as if they were proven empirical facts, and that this is impeding progress in crucial areas like consciousness and biology. The fact that his TEDx talk was censored, not because it was shown to be factually wrong, but simply because it challenged accepted orthodoxy, proves his point better than any argument he could have made. When a platform that supposedly celebrates innovative ideas removes a talk because it questions fundamental scientific dogma, it should be a wake-up call for us all. It shows that we are dealing not with open science and free inquiry, but with an ideology that defends itself against criticism in the same way that any religious fundamentalism does. And that is dangerous. It is dangerous for science, which thrives on skepticism and debate. It is dangerous for society, which needs science to be honest about its limits and uncertainties. And it is dangerous for individuals who need richer structures of meaning than the nihilism that materialism inevitably leads to. So what should you do with all this? How should you think about these ideas? First, I encourage you to be skeptical but open-minded. Don't accept Sheldrake's claims simply because they're appealing or because you want them to be true, but also don't reject them simply because they contradict what you learned in school or because mainstream scientists dismiss them. Investigate the evidence yourself. Read Sheldrake's books, examine his experiments, consider his arguments. Also, read his critics, see what they say, and see if their criticisms actually address the substance of his claims or are just rhetorical attacks. Form your own conclusions based on evidence and logic, not on authority or consensus. Second, pay attention to your own experiences. Have you ever experienced connection, synchronicity, premonition, telepathy, or other phenomena that seem to defy materialistic explanations? Most people have, but they dismiss them as coincidences or illusions because that's what we've been taught to do. But what if these experiences are real data about the nature of reality that deserve to be taken seriously? What if your direct experience is actually a more reliable guide to truth than abstract theories that deny the validity of that experience? Trust your own experience, but also test it. Examine it critically. See if it is consistent and replicable or just chance. Third, recognize that this isn't just an abstract question of scientific philosophy. How you think about the nature of reality profoundly affects how you live your life. If you believe you're just a biological machine doomed to non-being, that leads to one kind of life. If you believe you're part of an interconnected web of consciousness that extends across space and time, that your life has meaning and purpose beyond biological survival, that your connections with others are real and meaningful, that leads to a very different kind of life. I'm not saying you should adopt beliefs just because they make you feel better, but I am saying that truth and meaning are not orthogonal to each other, that a worldview that renders life meaningless and existence absurd should at least make us question whether we're asking the right questions and looking at the full evidence. Perhaps the fact that materialism leads to nihilism isn't just a nagging philosophical problem, but a sign that there's something fundamentally wrong with materialism as a comprehensive description of reality. And finally, consider the broader implications for how we do science and how we organize the pursuit of knowledge in our society. Should we allow a single philosophical paradigm, no matter how historically successful it has been, to monopolize what counts as legitimate knowledge? Should we allow the scientific establishment to act as gatekeeper, determining what questions can be asked and what evidence can be taken seriously? Or should we insist on a more pluralistic, more open, more genuinely empirical science that is willing to investigate phenomena and consider theories regardless of whether they fit within existing paradigms? These questions aren't just about Sheldrake's specific theory. They're about the nature of intellectual inquiry and the power structure of scientific authority. They're about who decides what is true and based on what criteria. And they're about whether we're willing to follow the evidence wherever it leads, even when that means challenging our deepest assumptions about the nature of reality. The story of Rupert Sheldrake and the theory that was banned from TED is ultimately a story of intellectual courage, the courage to question authority, the courage to follow inconvenient evidence, the courage to defend unpopular ideas, the courage to risk reputation and career in the pursuit of truth. Sheldrake could have had a comfortable and respected career working within the conventional paradigm. Instead, he chose to ask the hard questions, propose controversial theories, and face the scorn and ridicule of the scientific establishment. Whether he is right or wrong remains to be seen, but his willingness to challenge dogma, to insist that science be true to its own ideals of open empirical inquiry, is something we should all admire and emulate. Because, in the end, progress in science and human understanding does not come from defending established orthodoxies. It comes from heretics willing to think the unthinkable, question the unquestionable, and imagine possibilities beyond the limits of the currently accepted. Sheldrake is such a heretic, and that is precisely why his work is so important, so threatening to the establishment, and ultimately so potentially transformative. So I leave you with these questions. What kind of universe do you want to live in? A dead universe of meaningless matter blindly following mathematical laws, where consciousness is an illusion and meaning is self-deception? Or a living, interconnected, evolving universe where consciousness is fundamental and your life is part of a greater meaningful whole? Are you willing to consider evidence that challenges the materialist worldview, even when that evidence is dismissed by scientific? Consensus. And are you willing to trust your own experience and reason, rather than simply accept what authorities tell you to believe? These are not easy questions, and they do not have simple answers. But they are the most important questions you can ask, because the answers you give will determine not only what you believe about reality, but how you live your life, what values you hold, and what kind of future you work to create. Sheldrake's theory may or may not be correct in its specific details, but the questions it raises are absolutely critical, and his willingness to ask these questions in the face of overwhelming opposition from the establishment is exactly the kind of intellectual courage our age desperately needs. Now tell me, what do you think about all this? Does the theory of morphic resonance make sense to you, or do you think it's a step too far? Have you had experiences in your own life that seem to defy materialist explanations? And do you think Ted was justified in banning Sheldrake's talk, or was this unwarranted intellectual censorship? Leave your thoughts in the comments below, because these conversations are important, and the more people are willing to discuss these ideas openly, the closer. We come to a fuller understanding of reality. And if you found this video valuable, if it made you think differently about science, consciousness, and the nature of reality, then please like it, share it with others who might be interested in these profound questions, and subscribe to the channel because we will continue exploring the most controversial and challenging ideas at the intersection of science, philosophy, and spirituality. These are the conversations that truly matter, the ones that can potentially change not only what we know, but who we are and how we live. And they start with people like you being willing to question, think critically, and keep an open mind in the face of the unknown and the unexplained.